Beginning, we see the female mechanic putting effort into pulling the starter cord to activate the cycle of the internal combustion engine block. Using the impact wrench immediately shows a mindset of a professional and decisive mechanical approach. Continuous pulling forces, but there is no ignition, clearly indicating the combustion chamber is lacking fuel or has lost its electrical spark. A colleague assists in checking the machine's load to rule out external mechanical jamming from the frame. When the partner leaves, the girl has to diagnose the fault herself in this machine's power system. She walks over to the Honda scooter, which holds her specialized toolkit to begin the engine dismantling process. The technical toolbox is brought out. Methodical tool preparation is the ultimate principle in repair work. The combination wrench set is laid out, ready for deep intervention into the high-strength, load-bearing bolts. Loosening the base bolts to completely isolate the engine block from the threshing machine frame. The specialist carefully observes the mechanical clearance of the threshing drum shaft to ensure there is no parasitic drag. Using a wrench to completely remove the support bracket nuts, the tightening torque here is usually very high due to resonant vibration. Removing the V-belt drive completely severs the torque connection to take the engine block out. The single-cylinder engine block is lifted off the support frame, a testament to the mechanic's physical strength. Placing the equipment on the new workbench, an open environment helps minimize the risk of losing microcomponents. A general survey of the engine casing. The tightly clinging dirt can obscure microcracks on the aluminum block. Opening the toolbox, she quickly selects the right socket to handle the hexagonal flange covers of the casing body. Equipping the Makita impact wrench with a battery. This device provides extreme impact torque to help break loose rusted bolts. Unbolting the retaining covers of the pull starter, the disassembly speed is maximized, thanks to specialized power tools. Moving on to removing the side cover faceplate base, extreme care is needed here to avoid stripping the aluminum threads. The spark plug boot is pulled off, revealing the center of the high voltage electrical ignition system, which determines the life of the engine. Carefully cleaning the spark plug's ceramic insulator, soot buildup here will severely reduce the spark intensity. A close-up look at the electrode. Although the gap meets standards, the carbon layer shows the fuel mixture was once running rich. Checking the pulling stroke of the starter assembly, the clutch pawls still open correctly under centrifugal force. Test fitting the plastic cover parts to test the grip of the magnetic flywheel after the preliminary inspection. Placing the heat shield assembly into the correct position. This is the part that routes the airflow to cool the cylinder's cooling fins. Using the impact driver to temporarily secure the anchor points, the decisiveness in her actions is very impressive and accurate. The recoil spring of the starter assembly works perfectly, retracting the cord smoothly without any mechanical delay. Pressing down firmly on the engine and test pulling, the compression pressure is very good, proving the piston rings are still tightly sealed. The issue lies in the fuel line. Having determined the fault isn't in the ignition system, she redirects her analysis to the air intake and fuel system. Using the impact driver to unscrew the air filter housing, a clogged air filter will skew the air-fuel mixture ratio extremely severely. Loosening the flange nuts that secure the entire carburetor assembly to the intake manifold of the combustion cylinder block. Carefully detaching the thermal insulator gasket, this component prevents the engine block's heat from spreading and boiling the fuel in the carburetor. The carburetor intake manifold is completely exposed. This is the most complex fluid mechanical device of the small gas engine. Observing the overflow fuel lines and the mechanism of the throttle linkage to look for signs of binding at a micro level. Skillfully sliding the carburetor assembly off the locating studs. Avoid bending the mechanical throttle linkage rods. Remove the drain screw at the bottom of the float bowl. The sediment accumulated at the bottom is usually the culprit causing blockages in the main jet circuit. Detach the float bowl. Old fuel residue, left for a long time, will evaporate and degrade into a sticky gum film. The expert closely inspects the inner wall of the fuel bowl. The oxidized rust and sludge layer has clumped into quite a thick crust. If this scum and debris layer gets into the main jet, it will immediately kill the engine when increasing RPM or under load. Use a brush to roughly scrub off the large deposits. Mechanical action to break up the clumped surface is the first step, which is optimal. Shake the specialized carburetor cleaner spray can well. The strong spray pressure will penetrate and break down all microscopic dirt. 5. Spray the strong solvent directly into the fuel bowl. The solvent substances. Hydrocarbons immediately dissolve the long-standing fuel gum layer. Continue spraying to clear the air vents and the pilot fuel circuit. The clearance of this system of pressure capillaries is vital. Use a clean rag to wipe the chamber dry. The smoothness of the metal has returned, ensuring the flow is not turbulent. Reassemble the fuel float bowl. Carefully press the molded rubber O-ring into place, so the system achieves a perfect pressure seal. Reinstall this complex mechanism back onto the engine block intake manifold. The vacuum effect of the venturi depends on this gasket seal. Reattach the choke linkage rod. This joint controls mechanically the amount of oxygen going directly into the intake chamber. Begin processing the air intake filter assembly. The protective plastic frame is being removed to access the foam filter material. 4. Scrub the foam filter clean with a stiff brush. Silicone dust. Clogging the foam pores will cause a rich mixture and loss of significant power. 5. Scrape clean the mating surface of the filter base. A small surface pit is enough to let unfiltered dust go straight into the cylinder. Use a brush to scrub the remaining residue on the cover cap, resetting the aerodynamic resonance chamber of the intake pipe. Install the air filter assembly base flange into its correct position, 2 alignment studs extending from the throttle body. The polymer foam filter piece that was cleaned is pressed neatly into the compartment, acting as a vital lung protecting the engine. Close the airbox cover, completely sealing the entire intake chamber before tightening the screws to secure and prevent mechanical vibration. 4. Carefully wipe the outer cooling fins, keeping the alloy surface constantly clean so the convective heat transfer coefficient reaches its maximum. 5. Hand tighten the wing nut holding the air filter cover. A smart ergonomic design for quick maintenance out in the field. 6.1 Plug the diagnostic wire back in and connect the sensor. All contactless microcircuit connections must be perfectly smooth and not loose. The wind deflector directing the centrifugal airflow for the system. Support bracket is being secured to preserve the cooling pressure. The crankcase breather tube joint is also reconnected, ensuring excess gas circulation, so hydrocarbons are not discharged into the environment. The kinetic power of the impact wrench is utilized again to securely lock the connecting bolts of the chassis, preventing stripped threads on the cover. Continue to tighten the fuel tank anchor points. High-intensity vibrations at high RPM can crack the mounting brackets if loosely tightened. Finishing the final. Locking bolts on the cylinder head. Concluding the basic hardware reassembly cycle. The expert manually checks the bounce of the choke lever to ensure the governor spring system automatically compensates centrifugally for smooth throttle operation. 4. Stretch the mechanism of the automatic throttle arm to evaluate the dynamic friction of the return spring. The responsiveness is extremely crisp. Check the fuel tank cap. All one-way vent valves must work well to prevent creating a reverse vacuum effect. Use a socket to securely tighten the spark plug into the compression hole with just enough torque to deform the copper metal gasket, filling the micro gaps with compressed air. Attaching the silicone-coated high-tension coil to the spark plug, the electric field is ready to discharge thousands of volts to ignite. Using a clean cloth to wipe the engine block's cooling fins, completely preventing the risk of leftover chemicals burning when the engine heats up. Flipping the choke lever to the cold start position to force a rich fuel mixture into the combustion chamber, increasing the fuel evaporation pressure. Adjusting the pull starter handle. All restoration steps for the fuel system, air intake, and ignition are fully complete. The engine block is firmly secured using body weight, establishing a perfect stance to transmit maximum pulling force. Slowly pulling the starter rope to move the connecting rod and piston past the top dead center, where the compression ratio is highest. Drawing a full charge of air-fuel mixture into the cylinder, pulling decisively to release the torque. The characteristic roar of the internal combustion engine immediately sounds crisp and powerful, lifting the lively engine block and its violent vibrations back to its original working position. On the sturdy mounting base, skillfully lowering the machine into the U-shaped iron grooves. The center of gravity must be perfectly balanced across the 4 bolt holes. Inserting the 4 positioning bolts into the base brackets. This step determines the pulley alignment, preventing belt wear under heavy loads. Cross-tightening the bracket bolts so the mounting surface of the engine base is pressed down evenly, eliminating any excess harmonic vibrations generated. Slotting the V-belt into the flywheel's V-groove. The friction drive mechanism requires precise pulley tension on this surface. Turning the pulley by hand to force the V-belt deep into the groove, adjusting the contact angle to optimize the friction drive coefficient. The rice threshing machine strongly comes back to life. The threshing drum spins at high speed. A fantastic carburetor overhaul, proving expert-level skills. The technician removes the tarp covering the rice thresher, starting the mechanical maintenance process. Placing the seat in the correct position to ensure an accurate working posture. The specialized tool tray is brought out in preparation for dismantling the machine. The bottles of cleaning and lubricating solvents for rust or ready. Wearing protective gloves is a basic safety rule when doing repairs. Test pulling the starter cord on this 4-stroke gasoline engine, but it completely fails to start. The impact driver quickly removes the engine mount bolts, using a screwdriver, to manually detach the engine block from the frame. The engine assembly is lifted out to a convenient spot for diagnosis. Out in the field, the rice harvest requires the machinery to be ready. The girl carries her toolbox and moves to the second broken machine's location. The farmers are urging her to speed up the repairs so they can thresh the harvested rice. The rice thresher near the cowshed is waiting for engine restoration, using a wrench to remove the mounting nuts of the jammed engine assembly. The high vibration environment makes these bolts very difficult to remove. The faulty engine has been successfully detached and brought out for repair. Wrapping the spark plug cap in plastic like this will cause high voltage leaks. The machine won't start when pulled, a clear sign of losing the electrical spark. Visually inspecting the spark plug cap, moisture might have seeped in and caused a short circuit. Opening the toolbox, looking for a socket to remove the spark plug for inspection. Removing the engine cover for easy access to the ignition assembly. Peeling off the sloppy plastic wrap. Leakage will eliminate the spark at the electrode. Cleaning the spark plug base to prevent sand and gravel from entering the combustion chamber when dismantling. Using a socket to remove the spark plug, turning it counterclockwise to take the part out. The spark plug has been removed. Its color and electrode gap need to be evaluated. A new replacement part is prepared to troubleshoot the issue caused by the electrical system. This new spark plug boot will ensure insulation and absolute waterproofing. Attach the spark plug to the boot to check the tightness of the metal clamp. Although the old spark plug has a bit of carbon buildup, the porcelain surface is still in good condition. Screw the spark plug back into the cylinder head with just enough torque to avoid stripping the threads. Reconnect the wire and pull the starter again. The engine still shows no signs of starting. The cause might lie deeper, in the ignition cable or the IC coil. The copper core of the high-tension cable shows signs of crumbling and heavy oxidation. Cut off the damaged section of the wire to access the highly conductive copper core inside. Wrap it securely with electrical tape to prevent short-circuiting to the casing. Reattach the spark plug boot, but the engine remains completely dead when pulled. Definitely, the internal IC coil or the stator must be damaged. Tilt the machine to prepare for dismantling, the fan cover assembly, and the manual recoil starter. Removing the engine block requires additional specialized equipment, taken from the vehicle's trunk. Prepare a battery-powered impact, wrench, and rust-penetrating lubricant. The battery-powered impact wrench quickly removes the sheet metal protective cover. The bolts, stuck with dirt and sand, are easily overcome by the impact wrench. Use a knife to scrape away the dried dirt around the gaps before lifting off the cooling shroud. Continue removing the recoil starter assembly containing the starter spring. The magnetic flywheel is completely jammed by a large amount of tangled straw and hay. The tightly wound debris severed the wires and caused severe overheating. Carefully remove the dried grass to avoid breaking the plastic cooling fan blades. Use a brush to sweep the gaps clean, ensuring smooth cooling airflow. Discovering the burnt ignition IC coil. Use the battery wrench to remove the mounting screws and lift the magneto coil out. Its electromagnetic induction principle has failed. The magnetic steel core is rusted and has completely lost its ability to generate voltage. Take a brand new replacement ignition IC coil from the toolbox. The new plastic sheathed cable will ensure no leakage of tens of thousands of volts. Precisely align the gap between the IC coil and the flywheel magnet. The ideal magnetic flux gap of 0.2 to 0.4 mm will create the highest ignition efficiency. Tighten the IC coil securely. The high voltage generation system has been restored. Reinstall the starter cup, the initial pulling force transmission mechanism for the crankshaft. Connect the grounding signal wire to enable the engine kill switch feature. Clean the outer casing to remove mud and dirt obstructing. The cooling airflow. Use a specialized solution to remove built-up grime and protect the powder coating. Keeping the engine block clean is the simplest way to prevent overheating. Align the tabs of the cover into their correct positions on the engine body. Thread the bolts by hand first to avoid stripping the soft aluminum threads of the engine block. The battery wrench securely fastens the cover, sealing the airflow. Finishing the cover tightening, the machine has regained its original appearance. Reroute the high-tension cable to avoid contact with hot surfaces. The new spark plug boot is firmly connected, ensuring the ignition circuit is completely clear. Secure the gas cap in preparation for the practical test. Use a screwdriver to readjust the air screw on the carburetor. Prime the fuel, open the choke valve, and give a decisive pull to activate the magneto. The engine roars to life crisply. The electrical and mechanical systems have been perfectly restored.